Hello friends, I am back with a new project which I am sure you all will like. My project is to solve a social problem faced by the mute people in their day-to-day life. We all have come across such people who are devoid of speech and listen. Have you ever thought how difficult it is for them to communicate with the common man in their day-to-day life? They can communicate amongst themselves with the help of a special sign language, but this sign language is not understandable to all. That is where the problem begins. It is challenging for them to communicate with the common man. Also, for you and me, it is comfortable to give speeches on TED and other shows. But have you ever thought how challenging it is for them to take advantage of doing so? So my project revolves around this problem, and I thought of building an app which could recognize these signs made by these people, convert them to text and speech. So now let me show you a small demo of this project and explain you the back end working of the project. So as you guys can see here, there are three windows: a gesture window, a contour window, and the threshold window. Don't worry about the Anaconda prompt window, that is just for running the script. Yeah, the link to the script is given in the description below. You can just check it out. It's a GitHub repo. So these three windows, there is gesture, contours, and threshold. So what I'm doing is I'm actually switching on the video first, that is the gesture window. So after I get the image, I convert it into grayscale and then add Gaussian blur and a threshold value to get the threshold window, the black and white screen right there. So you can see there is a white portion and there is a black portion. So that white portion means that my hand has been detected. Now with the help of that, I get the contours. So in the contours window, you can see a black colored screen. So that black colored screen, you can see there is some outlines. Those are the contours. And with the help of that, I got the coordinates for the bounding box, that is the red colored box, as you can see. So I got the coordinates for the red colored box, the bounding box. And I also drew a hull, a convex hull. The convex hull is nothing but this green line surrounding my finger right there. So now we know that my hand has been detected. Now the next part is that we have to detect how many numbers are there. What is the number being shown? That is right now 1. So what I did was I found the area ratio, that is I found the area of the area within the convex hull, and I found the area of my finger, that is the contour area. I subtracted and found the area ratio. Okay, so once we have the area ratio, we know that this portion is a defect. Defect means that the portion which doesn't have anything, it's an empty space within the convex hull. So we know that that portion is a defect. So now what we do is we check how many defects are there and we add some dots. As you can see here in the slide, that there is, when you show 2, you see a small dot right there between my two fingers. So how do you get that? So what I did was that I first checked the angle formed between the two fingers. If the angle is less than 90, then we add a small dot, and if it is greater than 90, then we just ignore it. That's how I ignored the other defect and just kept in consideration the first defect. Now we have the dot, we have the defect, the number of defects, and then what I did, I just added 1 to the number of defects present in the screen. So that is 2. So that is the number of fingers that are being shown. So this is how the whole project is working. So let me just show you the entire output. This project detects 1, 2, 3, 4 and 5. So first, when I started doing this project, I used TensorFlow 2.0 and the Google's object detection API. And the problem I faced was the GPU. As we all know, TensorFlow is a very heavy library, and to run and train models with TensorFlow requires a GPU. So I thought let's try running it on Google Colab, which provides a free GPU. So I tried running it, but the next issue was that I could not connect my camera to Google Colab. Then I thought, how could I do it? And that's when I got to know about JavaScript API of Google Colab. But then after that, I had many errors while training the model. So I thought, let's not dwell on the same solution and find another solution. That's why I used OpenCV and Python only, and I did not use TensorFlow. This is only a small portion of the project, a tip of iceberg of the whole project. The whole communication involves hand signs, facial expressions, positions, and multiple words, alphabets, etc. It's a very huge process and a complicated one. As I didn't have a lot of time left, that's why I could only complete a very small portion of it. But in the future, I would like to complete this project, which would help my friends and the society. Thank you for watching. Please like, subscribe and share.